So in this session, that means the 12th week session, we are going to discuss a very important topic related to quality control and quality improvement of products and processes, and this topic is referred to as the robust design and the Taguchi method. Now there will be 5 sessions during this week, and the lecture wise, let me first tell you what are the topics we are going to cover. And when you learn all these topics, you will be basically learning the fundamentals of Taguchi method. As we have already mentioned during the week 2 lecture sessions, that the Taguchi method is used for quality improvement. So the fundamentals of Taguchi method, which we are going to discuss, if these fundamentals are applied, what you expect that the product quality will be continuously improved. In lecture 1, we are going to discuss Taguchi philosophy for quality improvement, the adjustment factor in Taguchi method. So you must have a very clear-cut idea about what is this adjustment factor and how identification of this adjustment factor is related to quality improvement, quality control activities in Taguchi method. In the next lecture session, lecture 2, we are going to discuss the quality loss function, variations of quadratic loss function, and how to compute the average quality loss under different conditions. During lecture 3, we will be referring to the classification of different kinds of parameters that we come across, and we will be discussing the topic called quality evaluations with a number of numerical examples. In lecture 4, we will discuss the determination of manufacturing tolerances, tolerance design and tolerancing, one of the key aspects in Taguchi method. And in the last lecture, that is in lecture 5, we will be referring to the signal to noise ratio as a performance measure, variance independent of or dependent to the mean. For nominal the best, smaller is better and larger is better quality characteristics. Okay, so this will be our coverage. Now let us first discuss the Taguchi philosophy for quality improvement, adjustment factor in Taguchi method, and quality control activities. So we will be very specific in identifying the quality control activities in Taguchi method. Now, so let us again go back in discussing the Taguchi method. Certain the references we have given in lecture 2 as well as in lecture 3. So I ask my students, the learners, to refer to the lecture, the week 2 lecture sessions, and by this time you know that how the quality has been defined by Taguchi. So we will restrict ourselves to the definition of quality given by Taguchi, and as you are already aware that the Taguchi method or the philosophy proposed by Taguchi, Genichi Taguchi, a Japanese engineer, was proposed by Taguchi to improve the quality of a product as well as the process. Now the tools and techniques under Taguchi method, they are referred to as offline quality control technique. That means it is expected that all these tools and techniques you use during the design stage. Now when you refer to this particular topic, the philosophy and experimental design principles proposed by Genichi Taguchi are discussed. In fact, as it is referred to as an offline quality control technique. So obviously, the technique or this method is supposed to be used at the prototyping stage. So while you refer to a prototyping of a particular product, now obviously you have to follow certain say experimental design principles, because you need to carry out a lot of experiments at the prototyping stage, and so that you must know that under what conditions the product is supposed to provide the best possible performance. Okay, so this is the first point to be remembered, that whatever the methods he has proposed, these are to be experimentally verified. Taguchi coins the term quality engineering. We have already defined what is quality engineering, objective of which is to design quality in every product and its processes. So not only we are referring to the product, we are also referring to the processes. Okay, so it's a total systems approach, you can say, and so you want to say incorporate the quality features in your product. So there must be a separate approach. It's not necessarily only through the design effort you are assured of the quality. So a separate approach called quality engineering approach you have to apply. Taguchi's philosophy and method support the theme of never-ending cycle of quality improvement. Like we never say that the design has been design of a product or a process has been fully matured. You can't conclude that. Similarly, you will never say that the quality of the product has reached its final level. Okay, so always, even we say that even if you say at this time that the quality is best, but we believe in the philosophy of the best can be bettered. Taguchi method is referred to as an offline quality control technique. This point already I have mentioned. We have already discussed the basic concept and approaches of Taguchi method during week 2. So I suggest that you refer to week 2 the lecture sessions. You will get an idea about what is Taguchi method and what is the basic objective of using Taguchi method. Just I will tell you at this point that the main objective of Taguchi of applying Taguchi method is to create a design which is referred to as the robust design. And if you are successful in creating a robust design, then you will say that the Taguchi method has been applied. There are numerous examples of robust products, and directly or indirectly the method you need to apply for creating a robust product, directly or indirectly you are referring to the Taguchi method. We have stated 3-step design methodology in Taguchi method as recommended by Taguchi. What are these 3 steps? The first step is the system design. We have already defined what do you mean by system design. Then you go for the parameter design, and the parameter design is referred to as the main aspect of Taguchi method. So many a time the system design is already there. What you need to do, whenever you start applying the Taguchi method, essentially you will be referring to the parameter design. So it lies at the heart of the Taguchi method, and then once the parameter design is over, then you go for the tolerance design. So this is referred to as a 3-step procedure. So we have already explained the concept of robust design. Now what is robustness? Let us again define robustness. That means you say a product is a robust only when you create a situation, you create a condition in which the product performance or the product quality is virtually not affected, or you can say that even if there is an effect, this effect is minimum. And the defect of what? That means effect of external as well as the internal noise factors. Okay, so once you say that the product has been designed in such a way that the effect of internal as well as the external say noise factors, uncontrollable noise factors, the effect is minimum on the performance of the product, then you say it is a robust product, and the design methodology which you apply to create such a condition is referred to as the robust design. So, in Taguchi method, an attempt is always made to identify the adjustment parameter or the factor. That means any exercise or any assignment or any project is given under Taguchi method, that means the first objective will be whether you are able to identify the so-called adjustment parameter or the factor or not. And this adjustment parameter or the factor you need to identify with respect to the output or response related quality characteristic. Is it okay? So, you have a product. So, from the product you need some kind of output, and output maybe 2 or 3 kinds of outputs. And how do you define this output? That means with respect to the output quality characteristics. So, sometimes they are also referred to as the response variables. Now, you have to create or you have to identify the process parameters and their values in such a way that that the value of the output related quality characteristic is acceptable to you, and it should be acceptable as well as it should be the best value. The process of identifying the adjustment factor, and that is the thing you have to do. That means you have to identify the adjustment factor, and once you can identify the adjustment factor, possibly in 99% of the cases you will be able to apply the Taguchi method. So, the process of identifying the adjustment factor is to be understood very clearly. I will give you an example. So, here is an example. Suppose the important output quality characteristic is the diameter of a component, say tube diameter, and how do you specify this output quality characteristics? That is y. That means y is a variable. The process is suppose the extrusion process or wire drawing process. Okay, the tubes are extruded from pellets. So, this is the process. So, before you start applying the Taguchi method, you must know what is the process details. That means what are the output quality characteristics, what are the input variables, what are the external noise factors, what are the parameters. Okay, all these details you must know, and you must be able to create the boundary line. Now, what you find that y is affected by a number of input variables. So, this is your knowledge base. You must have this knowledge. One such input variable that you have identified is the mole pressure x. So, the mole pressure is also a variable. That is why we say that it is referred to as x. It's clear. Now, what do you do? Now, you start collecting data, and what do you find that the target value of y is y0. Okay, there is target value, and this value you get against a value of x, that means the mole pressure, that is x0. So, whenever you use a kind of the press and the mole pressure you get, and when the mole pressure is x0, then you get a value of y0. Fine, so far it is okay. But what happens that always you cannot they get the value of x as x0 all the time. There will be variations. So, this is the variation, that means x0 plus minus delta x0. You cannot avoid this. So, with respect to the variability across x0, you will be also be getting a variability of y across y0. Now, what do you find in this particular case, that this variability is very high. Okay. So, that is why it is not acceptable even if you get y0, but in most of the time the values of x will be say either less than x0 or greater than x0 within this zone definitely. But what do you get? That means excessive variability around y0. Is it acceptable to you? Definitely it may not be acceptable to you. Is it okay? So now the question is, how do you control this variability in y0? One way you can do, like say you use a better quality press, okay, or you replace the existing the press with a new one, and obviously you may find that this variability gets reduced. That is one solution. But the question is that the new press, maybe the state of the art technology press, this may be very expensive in most of the cases. So you have to think of alternative. That means to what extent the existing process you can use, and you can reduce this variability, or the effect of variability you can reduce. Is it getting my point? That means whenever you try to use the Taguchi method, again you go back to your basics. That means, as I have been telling you, that any exercise on quality is essentially an exercise on variability. So if the variability is reduction is there, then you say that yes, that the quality exercise we have been carrying out. Now the alternatively, what you find, that if the value of x is x1, there will be variability across x1, this is acceptable, but surprisingly you get a value of y as y1, fine, but across y1 the variability is very less. Is it okay? So as far as variability is concerned, definitely you can opt for x1, fine, but then this y1 which you get, it is far off from the target. Is it okay? So you can control variability by changing say x0 to x1, but in that case you will be getting y1, not y0. Now as we have been telling you that if you apply Taguchi method, what do you try to do? You try to produce the output quality characteristics to its target value. So it is far off from the target value. So this is the problem you face. Target value of y is y0, for which the mole pressure x is to be set at x0. The relationship after data are collected and analyzed through experimentation is given below. So this is the relationship, and in majority of the cases the relationship is non-linear. So the problem I have already mentioned. Now the question is that what you need to do? That means you have to, by using the same process, you need to get the value of y0, as well as you need to reduce the variability from this level to this level. Okay, so that is the challenging assignment given to you. So how to do that? So here what do you need to do? That means the first thing, you have to thoroughly study the system or the process, and you have to identify the adjustment factor. So but before you start identifying this adjustment factor, there are certain key questions. Will you set the mole pressure at x0? Variability against y1 is acceptable, fine, but y1 is far away from target y0 and hence not acceptable. So these are the key issues to be dealt with. So what is the alternative? Yes, you can do that, but you need to change the press to a new one, may be very expensive. Is it okay? You can restrict yourself to x0, fine, but then make sure that around x0 the variability is very less, and if you can reduce the variability around x0, what do you expect? That the variability around y0 also may come down. Now in order to reduce this variability around x0, what you need to do? You need to, in majority of the cases, you need to go for replacement, and the replacement cost would be very expensive, and that's why it may not be preferred. Supposing it is not your choice in majority of the cases, how to get a condition by using the same press so that the variability across y0 is held at minimum. So this point I have already elaborated. For this condition to achieve, you have to identify the adjustment factor. How do you do that? Okay, so how do you do that? So that process I am going to explain. Now, what is an adjustment factor? An adjustment factor is that factor which has a linear relationship with y. Usually you will find that y is a function of say n number of x's. n may be say the 10, n may be 7, in certain cases n may be 20, even in certain cases n may be, the value of n could be as high as 100. Okay. So so in this case particularly, so suppose 3 or 4 factors, most what you can say, the critical factors you have identified, and you find that out of these factors which are affecting the value of y, one factor has a linear relationship with y. Okay, that means what you need to do, you have to collect data, you have to plot those the data points, okay, between the relevant the variables, and then you say that which particular factor has a linear relationship with y, and that factor you may define it as the adjustment factor. Now in this case, the pellet size z is found to have such a relationship with y. Is it okay? So value of z, like say suppose S0, that is the pellet size, so it has got a linear relationship, so you get a value of y0. And then if you change the pellet size from S0 to S1, and if you use the pellet size of S1, is the extrusion process, wire drawing process, so you get a value of say y1. So your target is y0. Is it okay? So with the help of this adjustment factor, how do you get the solution? So we set x at x1, get y at y1, change the pellet size from S1 to S0, and get the value of y from y1 to y0. Okay. So I repeat, we set x at x1, get y at y1, change the pellet size from S1 to S0, and get the value of y from y1 to y0. Okay. So we are getting the target value. Here we are assuming that other factors have no influence on pellet size. So this is the rule we follow, and what we have found, if you go through the case studies on Taguchi method, what you find that in majority of the cases, identification of such an adjustment factor is a possibility, majority of the cases, maybe 95% of the cases. But what is the basic condition? The basic conditions, you must have a thorough knowledge about the behavior of the process. That means what are the factors affecting the performance of the process, and you must know how the process has been designed. So all these the knowledge regarding the process performance, regarding process design, you must have this knowledge, and then only identification of an adjustment factor becomes easier. So Taguchi has demonstrated these applications in several of his case studies. Okay. Now before I conclude this session, now I will referring to the quality control activities during various product realization steps. What you have basically in the product realization steps, what is this product realization stage? That means first is the product design, we have already mentioned. The second stage is the manufacturing process design. Okay. The third one is the manufacturing, and the fourth one is the customer related activities. Okay. So these are the four the product realization steps we have. What we need to identify, that related to a particular product realization step, like say product design, how do you define the quality control activities? How do you identify the quality control activities related to system design, related to parameter design, related to tolerance design? That means these are the three steps, one after another, you have to follow if you apply Taguchi method. Okay. So ability to reduce effect of the noise factors, whether at the system design these external noise factors, whether you can reduce this effect, you say yes, countermeasure is possible. Unit to unit variation, This is another kind of noise factor, unit to unit variation, that is the ES. And what is the deterioration effect? That means it is a product deterioration. Yes, that means countermeasures at the system design you can take against those external as well as the internal noise factors. Let me explain what is this unit to unit variation. What you find that supposing you purchase say one product, say a TV for a particular brand, and your friend has also purchased the same brand. Is it okay? That means for the same company, the same model, the same say the TV he has also purchased. Now there is a possibility that regarding the performance of this model of a particular TV brand, okay, now you may have one opinion, your friend may have another opinion, and both are you are also correct and he or she is also correct. So now obviously I say that the performance is very good, whereas my friend says for the same model he is using the performance is not that good. Now how do you explain this difference in opinion? Obviously there has to be some unit to unit variation. So unit to unit variation you need to reduce, and this unit to unit variation is due to some internal noise factors. So at the system design level you need to take care of these aspects. Okay. Innovation activity to reduce sensitivity to all noise factors. Okay, these days we talk about innovation. So the innovation activity you must encourage. Most important steps for reducing sensitivity to all noise factors uses robust design method. That means I have already mentioned that the parameter design is the most important step. So here also against all these noise factors you can take the the countermeasures. So the product design, similarly the tolerance design stage you can have the countermeasures. That means method for selecting most economical grades of materials, components and manufacturing equipment and operating environment for the product. This you do at the product design stage. And similarly when you refer to the next step, we go to the next the realization step, product realization step, that is the manufacturing process design. Again, as far as system design is concerned, at the process stage, that means the external noise factors, there cannot be any countermeasures against noise factors. Okay. Whereas unit to unit variation, internal noise, so there could be some the countermeasures, right? And here but the product deterioration you cannot take any countermeasures. So involves innovation to reduce unit to unit variation only. Okay. Similarly, when you reach the parameter design stage, against external noise factors there is no countermeasures. Similarly unit to unit variation there will be some countermeasures, but against product deterioration there is no countermeasure. So important for reducing sensitivity of unit to unit variation to manufacturing variations. And when you reach the tolerance design, again you have the same the conditions you have against taking preventive measures to control the effect of so the external as well as the internal noise factors. Now then we move to the manufacturing stage. Obviously you will find that there will be at the detection or the correction stage, is it okay, quality control activity. So you have unit to unit say against unit to unit variation you have some action you can take. Feed forward control, there is a part of the system, again unit to unit say unit to unit external the noise factors, internal noise factors, you can have the countermeasures. And for the screening, say you can have the countermeasure against unit to unit variation. And when you talk about the customer uses, warranty and repair, so that is very important aspect, warranty and repair. We are referring to the quality loop, so please refer to the quality loop, and you will find that the customer uses, when you reach at this stage, nothing you can do. That means, as far as controlling of the external noise factors, you cannot do at the customer user stage. Is it okay? So, this is the approach. And what are the quality control activities related to quality engineering? Offline quality control, online quality control. Online quality control based tools and techniques we have already discussed. As far as offline quality control is concerned, we say that we refer to the design of experiments. Then through design of experiments, you identify the sources of variation, and we opt for the design optimization. And then we refer to the product design. Again, we refer to the process design. So here on this the domain will be using the Taguchi method, and obviously when you refer to the online quality control, we refer to the process control. So we conclude these sessions. We will be referring to the next topic in the next session.